My name is Alessandro. I work at Microsoft, but today I'm not wearing the Microsoft hat. I'm wearing another hat, which is the pirate hat. So that's. I hope it doesn't interfere with the microphone. So today I'm wearing a different hat because that's what I wear. I have a lot of hats at home, and today I decided to wear this one because I have a new project, and if you know me, I have a lot of ideas, a lot of projects. So I know you didn't sign up for this, so you're gonna just endure 5 minutes of talking about cloud pirates, and then we're gonna just dive right into GitOps and the security for GitOps and what does it mean to me and what I learned about doing security in the GitOps context. So what is cloud pirates? Who here is a freelancer? So did you ever hear the phrase, why join the Navy when you can be a pirate, right? So attributed to Steve Jobs. So I'm also a freelancer. I'm a trainer for the Cloud Native Computing for the Linux Foundation for Kubernetes. And I know a lot of freelancers in the industry, and I was wondering how many were here. So freelancers are, especially in the cloud native space, there's a lot. I know a lot of them. They are interesting people that really like to help each other. But and you know, Corona, these recent lockdowns, they isolate ourselves, right? So we work much in isolation. We lost the network. So I had this idea a few months ago to open a co-working space, a collaboration space, more like a permanent meetup, a place where people can just meet, get together, collaborate, and try to restore that in-person, that close contact and collaboration that was so important before. So me and two friends, two of my best friends, one is here, Fabrizio, we rented and we're gonna open the space in a couple of weeks in Amsterdam. And please sign up for updates. We also have a Twitter account. The space is much better now, so there is a floor and there is we paint it. Just I don't have recent pictures, but it's gonna be a place where we can have meetups, small conferences. We can have just a coffee together. We can just create something together. So it's our project. We invest a lot in it, and we would love to see the idea pick up in other cities. So our measure of success is not about the money. We're not gonna make any money out of it. We're probably gonna lose a bit. But what we want to see is that we bring back this collaboration after so many months of isolation because of the virus. We're gonna be safe, so we're gonna ask everybody to show proof of vaccination or a negative test. But once you are in, you can collaborate. You can rent a desk. You can use it as your place of work. You can use it as a place where you can organize small workshops, or you can meet same people working in the same space. So let me take the hat out because it's very hot, and let's talk about GitOps. You are here for this. So there is, who knows what GitOps is? I think it's pretty common to know, to hear about GitOps today. And for me, it's an evolution, right? So I started doing computing 10 years ago, more or less, but I've been around Linux and open source for more than 25 years. And you've seen this, right? So you start from ad hoc servers, everyone individually cared for, each one special in his own, and then you start to do infrastructure as code, you move to the cloud. I remember when AWS came along, and everybody was so excited about it, and look at it now. And then that's where I started also doing communities. I started the DevOps meetup in Amsterdam 11 years ago. We started to do DevOps, and at the time it was right after the first DevOps days in Ghent, the very first one. We started doing that, and then it was still like a new thing, and now DevOps is just the way we think about how to organize teams, how to organize organization, and how to deploy infrastructure. But of course, what was missing in there was including security in DevOps. So DevSecops is even a more recent incarnation or more recent way of thinking about DevOps. And finally, GitOps came along just a few years ago, where we turned the paradigm of deploying infrastructure on its head, and instead of pushing, we pull. The model is now pull, and I'll show you in a bit. So that's a short history of GitOps, thanks to WeWorks. So it's WeWorks is really the main proponent of GitOps. Thanks to them, we talked today about GitOps, and thanks to especially Alex Richardson, which is, I think he was also sitting in the CNCF TOC. I'm a CNCF ambassador, so I'm quite close to this community, and I'm happy that now GitOps is also part of of CNCF in the form of the working group. So you can see, starting 2017, 2018, we started to talk about GitOps. So the first incarnation, the first Flux controller was released shortly after, and then Argo came to the scene, and now we really talk about GitOps as the way to manage complex infrastructure and complex applications at scale. So, and today, this year, last year and this year, there were a lot of GitOps conferences, GitOpsCon, GitOps Days. So there's a co-located event with KubeCon, and there's specialized events like GitOps Days, mostly run by WeWorks, but there's many more players on the market, and it's been adopted by cloud providers like Azure and AWS and Google Cloud, of course. So GitOps has now a working group. So in CF, in the Cloud Native Computing Foundation, we have, of course, working groups, which are specialized communities within a big community, which is CNCF, where they work on on one topic, right? So, and then the GitOps working group, it's great, it's very open, everybody can contribute to, and they run GitOpsCon, co-located with KubeCon, and they work on a definition of GitOps, right? So, and that's of course like within the larger cloud native definition. They came to this definition after some discussion, of course. So it's a technology pattern for distributed system management. Very, very generic, but it's something like an operating model for cloud native applications. So it's about how you deploy, how to manage application in the cloud. Not only application, it's also applicable to infrastructure, is applicable to security, as we're gonna see, and it's important to, it's one of the newest concepts, but also one that is very quickly taking over the way we think of how we deploy applications. So, and it's about principles and not technologies. Like many cloud native approaches, it's not the specific technology, it's about the principle behind it. So first of all, it's declarative, right? So we completely abandon the imperative way of describing application and infrastructure. We completely adopt the declarative way. So what does it mean? We declare a state through some DSL, through some language. There is still a bit of fuzziness in which language we should talk about GitOps. So there's this Helm releases and Argo application and so many other ways to declare what an application looks like or how it should be deployed. I hope soon there will be a bit more of homogeneity in how we declare this application, but the idea is that we declare it, we use a declarative way to describe this application. So next is everything is version. So these declarations, these manifests are stored in a version control system. Not per se Git, doesn't need to be Git per se. So Git, of course, is the way to, the most popular VCS out there, but doesn't need to be Git. I mean, you can use ServiceNow, and there's or you can use Arbor. This is just to simplify a registry, so you can store these definitions any way you want, even in ServiceNow as I don't know, tickets. I never use it myself, but of course, like 99% of the implementation you see out there are based on Git, and especially, of course, GitHub, because it's one of the most popular Git platforms there. And then the next component is the controller, right? So there is a control loop that enforce those declarations, those manifests into your platform. So we'll talk about this video in detail, and then the next thing is a software agent. So who does the controlling? A software agent running on your platform. And then the software agent can be the implementation that you can think of, Flux, Argo. Those are the two most popular. I think other players have slightly different implementation, but most of them, they rely on these simple but very powerful controllers running on platforms. So, and it's not only Kubernetes. So you can use GitOps to manage infrastructure in Azure or AWS or Google Cloud. You can use Terraform to enforce. If your declaration, if your manifests are Terraform manifest, you can have a software agent that enforce those, that applies this this manifest via Terraform to your infrastructure of choice. So and all this together makes for a shift in how we think, and that's also why security is so easy to achieve with GitOps. So push versus pull. So until now, we always look at the classic software development chain as I'm a developer, I write code, and my code ends up in GitHub, and my CI/CD system picks it up from there, reads from GitHub, it's alerted or notified by a GitHub webhook or something like that something has changed, and then writes to a cluster. So what's wrong with this? It's nothing really wrong per se. I mean, we've been doing it for a decade, but there is something wrong there in the sense that I need to have credentials to write to my cluster in my CI/CD system. So I need to have a Jenkins secret, GitHub secret, some sort of credential that needs to be part of my CI/CD system. So Jenkins, GitHub Actions, whatever, writes to my cluster. It's okay, but it's also, you are exposing those credentials to take over. So if you compromise the CI/CD system, it's game over. You don't have any protection. Your cluster is wide open. Usually the CI/CD systems, they can write to multiple namespaces. Many times they have admin capabilities on clusters, on multiple clusters if you manage multiple clusters. So it's not ideal. We've been doing it, but is there a better way? Yes, there is. It's what we call GitOps. So in GitOps, you still write code and you still push it to GitHub or to Git. You probably create Docker images out of it, and then you have a GitOps controller running either inside or outside your cluster. So in this case, which is most popular, most common, the GitOps controller is part of the cluster. So of course, has access to the cluster because it runs inside of it. So you use service account in Kubernetes or other ways to access the cluster. But what matters is that no one has to embed or write or copy secrets or kubeconfigs out of the cluster into a CI/CD system. So the CI/CD system, the GitOps controller is the CI/CD system and has only read access to Git. In some other ways, in some other system like Flux, you also have write access to Git, but it's not necessary to operate. And if you look at Argo in fact doesn't have any way to write back to Git, but Flux does. It is really just a detail. But what matters is that I don't need to set these credentials anywhere. So that's very important. Also, What matters is that I don't have access directly to the cluster, so I cannot change anything in the cluster, or at least we tend not to distribute even or give kubectl binary to developers anymore. So the only way developers can access the cluster is through the version control system, the VCS. So it's a bit of a change. People cannot feed all kubectl anymore, but that's for a good reason. So they cannot manually change state of the cluster. So every change has to go through version control system, which means, of course, like either pushing directly or pull request. And in fact, one of the definitions of GitOps is operation by pull request, as in I change a manifest, I collaborate with my colleagues, with other developers to change the state, and the state is stored in Git, and then that's applied on my cluster. So that's how it works, and this is the beauty of GitOps, right? So this is what makes GitOps powerful and more secure, because we don't need to embed a credential anywhere. And of course, you can also run this GitOps controller outside the cluster, or it can use one GitOps controller, maybe running in one cluster, but managing multiple clusters, and so on and so forth. It's also a pretty valid way to operate, and that's how it works. So, what also this control state implies is that this is a very known concept in Kubernetes, right? So it's the desired state control loop state machine, right? So you have a desired state and you have an actual state, right? So you have running infrastructure with Kubernetes cluster with probably some stuff running in it, like pods and services, ingress, whatever, and then you have a desired state storing it. So where is this magic? Who does this magic? This GitOps controller operator continuously compares the desired state with the actual state, and then computes the differences to be applied to the actual state. So converge the actual state to the desired state. So that's it's controls. It's applied. It is a concept from manufacturing that's been very studied in very much detail. We know how it works. It's very easy to implement. If you work with Kubernetes, you know how to enforce this control loop. So it's very straightforward. So now that we define what is GitOps and what's different about GitOps instead of the regular CI/CD tools, the CIOps. So we look at the differences between DevOps and GitOps. It's one common question, right? So am I doing DevOps because I'm doing GitOps? It's not quite, but the concepts are, I say, orthogonal, or you should think about them in a different way, right? So of course, the focus of DevOps is the culture, automation, observability, right? So DevOps is not only how you deploy infrastructure or application. DevOps is really a culture, and for me, it's I always thought about DevOps as an ethos, like more of a way to think about your work than anything else. I mean, not just the tool of the jour, but also how to relate with your colleagues, right? So DevOps, for me, the focus is more on the culture, and instead of just the tools. While GitOps, the focus is more about the principle, like the tenant, the guidelines of how you think about how you think about application infrastructure. The tools are different, of course. So DevOps classically has been done with the CI/CD tools like Jenkins or GitHub Actions. It doesn't matter really the tool, but it's very much focused on and based upon CI/CD, while GitOps is based on these state machine controllers. DevOps is a more flexible approach, so you can pick and choose. You can be more open in what you choose for your how you think about DevOps. While GitOps is really quite strict. I mean, if you don't do if you don't have this paradigm of pooling, it's really not GitOps. So it's a bit more strict in what implies. And security is, so DevOps, we applied security post facto, as in we have to think proactively about security, like protecting those secrets, protecting those credentials, while GitOps is sort of built-in security, which makes it a bit easier on the on security. So, sure. Why is built-in? Because I am not even able to inject any secrets. There is no CI/CD tooling, so I'm doing when I do GitOps, automatically I don't have to embed any secret in my CI/CD tool. There is no CI/CD tool. I just deploy a controller in my cluster, and that pulls the configuration. So I'm sure that there is no leakage possible of credentials into the wild. So we may argue with that. It's not definitely, it's not clear cut, but it's for me, I don't even need to deal with the secrets in GitOps because I know that they are, the way I deploy it, it's built-in secure. But sure, you can also shoot yourself in the foot with GitOps, with Flux. You can do crazy stuff. You can do not so secure GitOps as well, but usually the defaults are more safe than the classic, I don't know, Jenkins plugin for Kubernetes or managing Kubernetes clusters with Azure DevOps, right? So you need to be proactive and allow your CI/CD tool to operate on the cluster, while if you use GitOps, the cluster will pull the configuration from Git. You still have to think about security. I have a comment later, but well, I'll come to that later. I hope it's good enough answer. Otherwise, we can talk over beers later. So this is why I think GitOps is inherently secure. It's immutability firewall. It's a concept also explained in that blog. So there is a clear separation between Git, the report, what happens before, what happens on the left, and what happens on the right. So there's the only interface is really the code. So as long as you scan the code, of course, it doesn't make you automatically safe because you still have to scan the code for vulnerability. If you use Node.js and use a npm package that is inherently insecure, then GitOps is not going to help you, but at least it won't let you leak credentials or so easily like if you use a CI/CD tools, at least better. So there's this firewall, this separation between the left and right. You have the loop, the dev loop, developers loop, like they test, they build the code, and then they store that code in Git. And then what happens on the right is all conserved for the GitOps controller, which will deploy, observe, operate as well the code for you on the cluster. So what happens? So GitSecops, there's more integrity because, first of all, if we are only looking at Git, we have automatic auditing. So we know who pushed what, who approved which pull request. We know what change went on in each piece of code, in each line of code. So, and we have a single source of truth. We can always refer to the actual state, to the Git commit that created the state. So we can actually trace back whatever changed to the infrastructure of the application to changes in Git. So that's a pretty good advantage. Because we can do that, we also have automatic disaster recovery. We can just roll back the changes in Git, and the infrastructure will converge back to a previous point in time. So it's a built-in disaster recovery, DR, business continuity paradigm or use, and we shift left security. And one thing that's quite important for me is that no humans are allowed to touch the infrastructure. So no kubectl means way less drift from desired state. So there's no way to change a cluster without changing the state in Git. So that's pretty important for me, and that's I feel much better not having to do so many kubectl commands, and I know that more people can collaborate. I know I can see what my colleagues are doing because everybody has to work on the same repository. We have more visibility. We also improve each other, right? So that's why we collaborate over Git. Pull requests are meant for this. They just help you work together in a better way. So it's not all roses and beautiful landscape. It's also introduce. It doesn't eliminate the need for security, but just shift it somewhere else, like a partial shift. So for example, Git, usually people tend to just make an account on GitHub and start pushing changes, but it's not the right way to do it. So, and I also learned myself now. I have a GPG key in my GitHub account, and I also have a two-factor authentication. So every commit I'm doing, I'm forced to authenticate myself, and means that first of all, we are, at least in the project I'm involved in, we're much better with Git security, so we learn much more about being more proactive, more strict on Git commits. So no pushing to main. We protect branches. Branches are, at least the way I do it, the way we do it, we map branches to environments. So some environments are protected because we don't want to change environments with just a simple commit. We want to go through a auditing process through a pull request. So we look at audit logs, we save logs, so we know who pushed what and when. We sign commits, so with GPG, it's pretty good practice to do. It's a bit more laborious, but it's really good to do. We rotate keys, so we don't allow the same key, because if somebody steals my key, it's like an SSH key, right? So you can just impersonate me and push code that is probably containing. Maybe instead of pulling a armless Nginx Docker image, you can pull some Bitcoin miner or a Monero miner and take over the cluster like this. We also have more structured repo for that. So, and we can also keep the clients updated, because Git is a great software, but it's not perfect. It's made by Linus Torvalds after all, so it's sometimes Git contains as vulnerabilities, as was recently shown. So now we talk about GitOps security. We know that we are in a better place because we use GitOps now. But what about multiple clusters? So that also is simplified by using GitOps, because clusters are now just ephemeral entities that we can just create also through GitOps. And I have a repo out on GitHub. I forgot to put the link, but it's, you can reach out to me, I can send it, I can push it later. We can create multiple clusters through GitOps, and we can create the apps that goes in the cluster also through GitOps. So imagine having a fleet of clusters all managed through GitOps. And there's a project out there, part of the Kubernetes project, called the Cluster API, which again describes clusters in a declarative way. So let's see, like, resonates with the GitOps principles. So you can create those clusters with the Cluster API manifests. So you can define your clusters as objects, as Kubernetes objects, as CRDs, and then those clusters are created in your cloud of choice, VMware, Azure, Google Cloud, and then deploy application in it via Helm with another or the same GitOps controller. So the idea is that you scale infrastructure, you scale the cluster, you also scale the complexity. That's why GitOps comes to rescue for that. So I have one example, and I think you can also check Stira boot for Open Policy Agent, which is a very powerful way to declare. Because Kubernetes, everything is declared. You declare policies through code. So you declare policies like, I don't want any container running as root in my cluster. I don't want to pull any images from Docker Hub. I want all my ingress controllers to be private IPs instead of public. Now imagine taking all these declarations, take all these policies, embedding them, pushing them to a repository, and then a GitOps controller can deploy them at scale to your cluster. So you can store and edit policies centrally. You can test the policies centrally. You can test them for every commit you do. You can test them on a subset of your fleet, and then cascade those changes to the rest of the fleet. It's all very good. It's all very automated. So also no question if that policy is applied to a specific cluster, because you can be sure that if it's in Git and the GitOps controller is not reporting any error, the policy is applied. The policy at that specific Git commit is applied to the cluster or to the clusters that you want. Why? By testing.
Between your Argo CD and the open policy.
Yeah.
Oh, yeah, sorry, I should repeat it for the stream.
Yeah.
The question I asked was if I have a GitOps process and an admission controller by open policy agent, and the developer creates something which the open policy agent prevents, then the Argo CD say, please do it, and trace to reduce the drift, and the open policy agent says no, and the Argo CD says yes, no, so you have an infinite loop.
Yeah,
how do you solve it, and how do you want to make sure that the developer can correct it by notifying, to get notifications about this?
I've been there. So indeed, Argo sometimes tries to change something, and then something else changes it again, right? So because there are admission controllers, in AKS, in Azure Kubernetes Service, we do have like a bunch of stuff that it's enforced by the platform. Sometimes some cluster are this, but then you will see that Argo will never converge to green state, to complete state, and then you can get notification out of it. So yes, that's why testing is not going away because you're doing GitOps. Testing is still important. You should test on an environment that will give you proof and will give you a sample of what's going on. So yeah, it's non-resolvable, I think, unless you actively solve the conflict. So yes, I've been doing that for Cert Manager, was always yellow, and I spent inordinate amount of time trying to figure it out. It was because AKS was changing some state to some weird stuff. Then I decided to let Argo ignore that particular field that was keep changing because of the platform. And then I finally get green, and then if it's green, it's good. But yes, but if it's a bit more complicated problem, like Argo wants to pull from Docker Hub, there is a policy that prevents, then you will see very evidently in the dashboard, or Argo has also a notification to Slack or Teams or somewhere. You can see it. So test it in a subset of clusters and then try to solve it there. So that's what I would do. Okay, that concludes my talk. I don't know if we are on time. 5 minutes, I have time for questions. Don't miss other GitOps talks today. There is one from Kubernetes. Yesterday there was one, unfortunately I missed it. And there's a bunch of links in there. And don't forget, if you want to be a pilot, you can take a business card, and you can always contact me. We have a long journey ahead. It's a big effort to be a pilot, but it's very rewarding. And if you want to know more, just contact me. So that's any questions? Any more questions?
Do we have any questions? Okay, if not, thank you very much. One more time, big applause.